Hello guys, I'm going to make this video. I hope you can hear me. I'm a little under the weather, but I think this will be better than nothing. So this is our last day of prerequisite skills. And yes, the quiz is still tomorrow. I've posted the practice key for the quiz. That should have been half your homework. And I will obviously post the other half on radicals for you to check how you did on the last lesson. Okay, so our last thing we need to cover before we get this year started in geometry, and remember, we're starting with constructions, so make sure you get your compasses for home use. I have some for school use. Okay, so this lesson, we're going to learn two very important formulas that go along with our slope formula. Right? We talked about that last time. So now we're going to talk about, well, how do you find the midpoint and how do you find the distance between 2 points, otherwise known as length of a segment? Okay, but since your quiz is next class, I want you to practice. So take a look at the warm-up, right? There we have 3 questions, right? A little slope review as well. Okay, I want you to pause the video and try these, and then we'll go over them. Okay, so let's look at number 1. How do we find the slope between 2 points? Well, we're going to use the slope formula, which is right here. Remember, slope is a number, right? And what do we need to do? We need to subtract the y's. So I'm going to underline the y's, 7 minus 6. And then if I underline the y's, then I know the remaining numbers must be my x's. Don't drop the -2, right? It's 8 minus -2, right? We're always finding the difference between those numbers. You can put this in your calculator, use your alpha y equals fraction bar, and if you do that, you should have gotten 1/10. Okay, let's look at the second question. Okay, how do we do on this one? So this one we had to think a little bit that we have segments that are parallel. Well, what does that mean to us? Oh, yes, parallel slopes, right? Parallel lines will have the same slope. Bing. Okay, so that means that the slope of our s, which they gave us is 5/8, would have to equal x over 24, right? Same slope. All right. You recognize this, I hope. This is just a proportion, right? Product of the means equals product of extremes, right? Divide by 8 on both sides. And we should have gotten 15, which is good to know because that's one of the multiple choice answers. Whoop, whoop. Okay, let's look at this number 3. What is the equation of a line? Okay, that's what it's asking for. That is parallel, again, important, to a line whose equation is y equals x plus 2. Well, we just discussed that parallel lines will have the same slope. So since this is in y equals mx plus b form, right, I know the number before the x is 1. So I know the slope of that line is 1. Now all I have to do is tweak my multiple choice answers to get them in y equals mx plus b and see who has the matching slope of 1, right? So if you look at the first one, all right, I'm going to get y alone. That means I'm going to subtract the x. Well, I can stop right there because that's a -1. You're not it, right? And again, you don't really even have to do the second one in the sense that to get y alone, you would be subtracting 2x, right? Well, that's going to be a slope of -2 when I move it over. It's not a 1, so I don't have to do too much work there. If I look at the third one, I'm going to be adding x to both sides. Oh, that's a slope of 1. Winner, winner. Okay, pause the video, and you got one more warm-up page. Try your best. All right, let's see how you did. So let's look at number 4. Again, it's that which equation represents a line parallel. Okay, so that means they have to have the same slope. But then there's a little additional information. It has to pass through this point. So now notice I'm dealing with point slope form. because all the multiple choice are in this point slope form. Right? And notice that I'm putting in a 1 and a 3. So instantly, right, I could replace this with my 3 and replace that with my 1. Okay, so that's a little bit helpful because 3 and 4 have plus plus. All right, now I got it down to 50-50, right? So now I really have to look at, I know, this is not in a friendly form. So I got to get this again in y equals mx plus b. I'm going to add 2x to both sides. Remember, when you move something, it changes its sign as you go across the equal sign. All right, but y is still not alone, so you have to divide everybody by 3. And all I care about is that the slope is 2/3, right? Because parallel lines will have the same slope. So that makes it pretty easy. Choice 2 has the 2/3 slope. Okay, now it says find the slope of a line perpendicular to this line. Okay, now remember, perpendicular lines, right, a little bit different. They'll have negative reciprocal slopes. But again, this is not user-friendly, so I have to get it in y equals mx plus b form, which basically means get the y all by itself. So I'm going to move minus 6x over, and it becomes positive 6x. Right? Then I'm going to divide everybody by the 2, because again, I want that y alone. And notice what I discover is that the slope is 3. Okay, now all this says is, well, what slope, right, would make another line perpendicular to this? So negative reciprocal slopes, right? How do I take the negative reciprocal? Well, if this is positive, then this is negative. They have to be opposite signs. Then you got to flip it. So 3 over 1 is 1/3. Easy peasy. Okay, but I did make one to challenge you, right? That this would be, all right, the most challenging because all we have is 2 points that lie on this line. And we have to find the point slope, right, form of the equation. Okay, so obviously point slope starts with slope again. That's why it's so important we know how to find the slope. So I'm going to underline my y's, and then I'm going to subtract them. 5 minus negative 3. Then my x's are 0 minus 4. And again, you can put this in your calculator because you don't want to get this number wrong. Okay, so cool. Now I have the slope. Now I can pick either point and get the answer correct, right? Because in point slope, I just need a point that passes through, right? So if you pick 0, 5, right? I'll say if I pick 0, 5, then I get y minus 5, because it's y minus the y value, equals negative 2. And then at first you may want to think of x minus 0, but wait a second. You really wouldn't write that because x minus 0 is just an x, right? In fact, this is the y-intercept, right? So that makes sense. So final answer, y minus 5 equals negative 2x. But you could have used the other point as well if you wanted to. Okay, I hope that was a really good review for you. And again, study the first 2 lessons, okay? I spent this time going over the slope and the linear, but you still have to know your basic algebra from day 1, which is solving those fractional equations. So look over your practice quiz. But now we're going to get started on the lesson. Okay, so the first thing we're going to look at, right, is a graphing example of how do we find the distance between 2 points. So I've given myself a little head start, so I want you to follow my example. It says, right, there's the directions right on the page. Would you graph negative 6, 3, that's your point M, and then graph 4, 2, that's your point E. Now, connect that. You can use your straight line and the shapes, and now you have a segment. Because when you are finding the distance between 2 points, you're actually finding the length of a segment, right? Those are endpoints. Okay, So then it says, now using ME as the hypotenuse, sketch a right triangle. Okay, that's what I'm going to do, sketch a right triangle. Now, it doesn't matter if you go above or below, but definitely here is, oh, I don't want to be on shapes again. I'm just going to do that freehand. All right, so there is my right triangle coming down one and over. Okay, so now it says, what theorem is going to help me find the length of the hypotenuse of a right triangle? Well, we went over this last class. Yes, Pythagorean theorem. All right, and remember that ME is my C, right? And then here's my A and here's my B. It doesn't matter who's A and B, they're both legs. All right, so in order to do this, I obviously have to count. Well, A is only worth 1 unit, right? And if you count B, I believe you'll get 10. Okay, so now I can use that theorem. 1 squared plus 10 squared equals C squared. And 1 squared is 1, 10 squared is 100. That makes 101 equals C squared. And hopefully you remember how to undo a square root, because I want to know what C is. Undo a square by using the square root, right? And now you'll see there's 2 directives down here. Simplest radical form. Well, if you look at this and your perfect squares, there is no perfect square that divides into 101 evenly, so it is already simplified. Now, it says round to the nearest hundredth. So if you use your calculator and hit the square root of 101, you should get this number in your calculator. I'm just going to write a little bit of it. And round to the nearest hundredth means that 9 affects that 4 to go up by 1, right? Which makes sense because 10 squared is 100, so a tiny bit more than 10 is going to give us 101. All right, so now what we actually just did here, right, is I showed you how to use Pythagorean theorem, but we don't always have graph paper, especially when we get later in the year, which is why we're doing this. We're setting it up early so you can practice. By the time we get to these graphing proofs that we're going to do, you'll be experts. So sometimes I just want a fast formula, right? So what we've done is we've taken that example, and I have a little graph over here, and we said, look, anytime you have a diagonal length, A to B, you can make a right triangle, right? Easy, right? Drop from one of the points, go over from one of the points. We can always draw a right triangle. So that means we can always, right, count the legs. But think about that. If I don't have graph paper, how do I count the legs? Well, if you look here, right, this distance, really, I'm looking at the x's, right? I'm looking at that -3 and that 6, right? So really what I'm doing is subtracting, right? So that's why it's saying x2 minus x1, okay? And then if you look at, right, this other leg, oh, guess what? If I'm looking at 4, right, to 4, again, I'm going to be subtracting the y values. So instead of putting our A and B, right, what we're really doing is saying, okay, so this A is really the difference of the x's, and this B is really the difference of the y's. So let's look at that in A squared plus B squared equals C squared. Okay, so again, I'm going to replace A squared with, again, pretend I don't have graph paper and I'm not going to count. All right, there we have that. And then my B squared is going to be my difference in the y's equals C squared. Now remember, I want this formula to be handy dandy. I don't want it to solve for C squared. I want to get that distance, so I really want C. Okay, how do I undo that square? We saw it on the previous page. I take the square root of both sides. Okay, I'm almost there. Now, the only thing I'm going to do is rename my C, because it's a distance formula, I'm going to give it a D. And I'm just going to switch sides so you can see it like this. So D equals, the square root, and you can do x2 minus x1, or you can do the triangle x, which just means to subtract. It doesn't matter. There we have it. So now, right, if I'm given 2 points, I can just, right, subtract the x's and square them, subtract the y's and square them, add and take the square root, and I instantly get the distance. This is the distance formula. Okay, so I'm going to do an example with you. All right, so you see the question says, find the distance between 2 points. You'll notice no graph paper. Okay, that's why we have a formula, right? And I am going to tweak the formula for writing's sake to d equals the square root, because I'm pretty sure we all know what delta x squared means by now, and delta y squared. Subtract the x's, subtract the y's. Okay, so let's see how we do this. Okay, now, same way I'm going to do slope, right? I like to come up to my numbers, right, and make sure I'm grabbing the right 2 numbers. So I'm going to just make a really big square root. And now I want to grab the x's. So I'm going to underline my x's, right? 4 and 1. Okay, 4 minus 1 squared plus, right? So simple. And then I'm going to look at my y's. Now be careful that you don't drop a negative, okay? So that's going to be minus 5 minus a negative 2 squared. All right, now you can change the minus a negative 2 to plus, or you can just put it in your calculator. Okay, so when I put this in my calculator, what I don't want to do, okay, is I don't want to put the square root in, because if you put the square root in, then you're going to get a decimal. And this one is asking for simplest radical form. So all you want to do is make sure your computation under your radical is correct. Right? I think I can do 4 minus 1 in my head. Right? 4 minus 1 is 3. Right? So that's 3 squared. All right, if you need help on this one, as I said, add the opposite. That's negative 5 plus 2, which is negative 3. But remember, put it in parentheses. All our negatives are in parentheses. All right, and now let's see what I'm going to get. 3 squared is 9. And by the way, negative 3 squared is 9. All right, and now all I have is 9 plus 9 is 18. Now I've got my radical, but it's got to be in simplest form. All right, so you know your perfect squares, 1, 4, 9, 16. I don't even have to go that high, right? Who's the perfect square that goes in evenly? It's 9. So we write this as 9 times 2. And then remember the 9 is perfect. So he gets to come out as what? Well, what's the square root of 9? It's 3. 2 is not perfect, so he's staying in. Final answer. The distance between those points is 3 radical 2. Okay, so hopefully you followed me, but you know what time it is. It's time for you to show me the money. So here's your practice problem. Pause the video and give it a try. Here we go. I've got 2 for you. You got this. All right. I hope you finished the practice. You paused the video. So now do a checkaroo. So the first one, notice no tricky negatives, just so you could get that formula down. And this one was really nice because what's the square root of 25? It's 5. That was a perfect square one, right? So sometimes they come out to be perfect squares, and sometimes they don't. So if we look at number 2, you can see if you did that correctly that you got negative 6 squared. Remember, a negative squared is a positive. You are not going to have a negative distance. That's crazy. Okay, that's like Star Trek talk. There's no negative distance. Okay, only positive distances. So anytime you have a negative and you square it, it's going to be positive. So that's 36. And then 4 squared is 16. That gave us 52. And I simplified by picking my perfect square of 4. 4 times 13, but radical 4 comes out as a 2. So 2 radical 13 was the final answer. And that's all there is to distance formula. Okay, second and last formula of the day is the midpoint, right? And this should be pretty clear that midpoint, might be the middle of a segment. Okay, so let's graph this segment. Okay, I'm going to make this a little bit bigger so I can see. All right, so at -2, 3, I have an endpoint. And at 4, -5, I have an endpoint. And I am going to use my little straight line maker. Okay, there we go. All right, so now it says using the graph, could you find the middle of the segment? Okay, so let's think about that, right? Similar to what we did last time, if you kind of use the right triangle method, right? And you kind of count, okay, so how far am I going down? How far am I going over? Right? If you look at that, that's 8 and that's 6. Okay, well, let's think. Well, then how would I get to the middle? Right? You thinking about this? I take half of that, right? So I would go down 1, 2, 3, 4. Here's my 4. And I would go over 3. And hopefully I spy, yeah, that looks like the midpoint, right? Okay. So let's take a look and read that off the graph. It says, what are the coordinates? 1, -1. All right, but remember, that's doing it graphically. So now let's see if we can try to make a connection with just doing it mathematically, right? Because you may not always have graph paper. So notice that the next step says, now take the average of the x coordinates. I'm going to assume, and I hope I'm assuming correctly, that everyone remembers how to take an average of two numbers, right? We add and divide by 2. So the x coordinates, right, are -2 plus 4, adding them, dividing by 2. Well, that gives us 2 divided by 2 is 1. Ah, okay. Now let's take the average of the y coordinates, which are 3 and -5. 3 plus -5 divided by 2. That gives us -2 over 2, which gives us -1. Ah, do you see any connection? I'm hoping you do, right? Because that's going to be our midpoint formula. And very simply, I always say the midpoint formula, which is, by the way, a capital M, don't make a small m because that means slope, right, is really simple. Remember, first of all, a midpoint is going to get you a point. So we are talking about an ordered pair, right? And when I come up with a midpoint, I want a point, an x and a y value. And it said really on the other page how to do that. So I'm simply going to take the average of the x's, right? Just calling them x1 and x2 because they're different numbers. And then I'm going to take the average of the y's. And that's how I find the midpoint, right? You're really just averaging to get the middle. And that's really what an average does. It finds the middle. Okay, so let's do one together. Everybody, let's find the midpoint, right? Find the coordinates of the midpoint of a line segment that joins, right, those points. So we know our x's are 5 and 1. Going to take the average by adding and dividing by 2. We know our y's are 2 and 8. So we're going to take the average by adding and dividing by 2. And let's see. 6 divided by 2 is 3. 10 divided by 2 is 5. Whoop, whoop. Right? Pretty easy formula. Right? You're just taking the average of x's, average of y's. That gets you your point, x, y. All right. Now, I did it. Of course, I made it look easy because, well, we all know I'm pretty good at this by now, right? So now it's time for you to practice because you've got to get as good as me. All right, not all in one day, but you've got this. You can do it. So go to the next page, pause the video, and I want you to do these 2 practice problems. You've got it. Give it your best. Okay, here's the reveal. How did we do? Right? Average the x's, average the y's. And again, don't get the computation wrong. Just use your alpha y equals fraction key, plug in the numbers, and it will simplify it for you. Right? There's no reason to get this wrong. You've got a $100 calculator. Use it for good. Okay? So that was working the midpoint forward. There's one other little thing that we need to add today, and that is, well, what happens when you actually have an endpoint and the midpoint, but you're looking for the other endpoint? So think about that. Let's get a visual, because a visual is always very good, right? To see what's the heck she's talking about. Okay, so M is the midpoint of CD. The coordinates of C are 6, 10. So I'm going to go up to 6, 10, and that's my C. Now, look at what I have here. This is the midpoint. So at 1, 5, I've got the midpoint. Let me get my straight little line maker. Okay. Right, so this changes things a little bit visually, right? What am I looking for? Well, I'm looking for where the other endpoint is, the coordinates of D. So if you got to think about it, I've got like half the line segment because I have the endpoint and the midpoint. Can you kind of visualize, just roughly, where you think D is going to be? Right? And then how do we exactly find D? Well, think about it. It has to be a straight line segment, which means, right, the slope from C to M has to be the same from M to D, right? And the distance has to be the same. So how do I make sure that happens? Well, again, we did it earlier. If you just count how many boxes, right, down, that's 5. And if you count over, that's 5. So now, that's what I'm going to do. Everybody can count, right? Count carefully. 1, 2, 3, 4, 5. That's down. 1, 2, 3, 4, 5. That's D. Boom. I found D, which is -4, 0. So that's working it backwards. All right. And I wanted to show you the first time with the graph, but there are other ways we'll take in a moment, but I want you to practice one time with the graph so you've got this really good visual. All right. So you have a practice one right here. Right. So notice P is your endpoint. A, it says, read carefully, A is the midpoint. So that's your midpoint. All right, go to the graph. That'll give you half the line segment. Can you find the other half and then name those coordinates? Pause the video. Here you go. Okay, take a look. How did you do? Did you see this one was facing the other way, right? Because P is the endpoint, A is the midpoint. So that's half the line. So you had to go to the right this time, right? Because A was the middle, right? And then you're just counting up 1 over 6 and up 1 over 6. If you got 8, 8, good job. If you didn't, again, look at what I've done on the graph. Okay, so that's how we do this graphically. And then I just want to show you, since this question, if you get this, will always say the use of a graph is optional. On every Regents, you get scrap paper in the back. Okay, so I picked the same problem that we did graphically with the endpoint at C and the midpoint at M15, because we already know the answer, right? So this would be a good way to check different methods. So it's saying, is there another way that you can work backwards using the graph? Well, of course, there's more than, right, just using a graph. You think about, we had a formula, right, for midpoint. All right, I'm going to write that. M equals, right, the average of the x's, comma, the average of the y's. Right, and you know, right, with a formula, you can always work the formula backwards as well. So let's kind of plug in what I've got. Well, this time I've got the midpoint, right? So I've got the 1, 5. Now, I also have an x, right, and a y. I just don't have the other x and the other y. So let's take a look at what that looks like. That would be 6 plus x divided by 2, and that would be 10 plus y divided by 2. All right, so now what does this actually mean? Well, remember, right, this actually means that this 1, right, is the answer to that problem, right? 6 plus some x divided by 2 would give us the midpoint x value of 1. So now we can set that equation up. So 1 equals 6 plus x divided by 2. Now remember, we know how to solve using a fraction because I reviewed this with you. How do I get rid of that 2? I multiply both sides by 2. Gotta snicker the 2 in there. 2 goes away. 2 times 1 is 2. 2 equals 6 plus x. Notice when I subtract 6 from 2, I'm going to get -4. Okay, now I'm going to do the same thing with the y. So notice this 5 had better equal 10 plus y divided by 2. So 5 equals 10 plus y divided by 2, and we know how to get rid of that 2. Multiply both sides by 2. Clear the fractions. 10 equals 10 plus y. This one's pretty simple, I would say, right? Y equals 0. And we know that because we knew d was at -4, 0. So there you have it. All right, there's your -4, there's your 0. So if you like algebra, if that makes sense to you, then you can use the formula. If you're more of just a computation work backwards kind of person, like just give me a method, okay? Then I have an alternative for you people. It's not always one size fits all, right? So the process of reversing this formula, so look at the formula, is we're adding the x's, right? Dividing by 2, adding the y's, dividing by 2. So now let's reverse that. Instead of add, divide by 2, well, divide by 2 would turn out to be, how do I undo that? Oh, I would multiply by 2. And instead of adding, I would subtract. So we're going to undo, right, and work backwards. So I'm going to write that down for us. So the process is, if you like this way, is you double the midpoint, which is the same as multiplying by 2. So let's do that. The midpoint was 1.5. Multiply by 2, right? I'm going to get 2.10. Simple, right? We can all double the midpoint. And then, because in the formula it's add, now I want to subtract the endpoint. Subtract endpoint. So what does that look like? Well, again, I've got 2.10, and now I'm going to literally subtract the endpoint that I was given. And remember, come back up here. The endpoint is C at 6.10. 6.10. 2 minus 6 is -4. 10 minus 10 is 0. There you have it. Okay, so that really concludes what I had set up for the lesson. If there is still time in the block, okay, I would like you to try the challenge because it addresses 2 things. Do you know how to find a midpoint? And do you know how to find a distance? So if there's time now, pause the video, okay, and try this, and I'll put up the answers. If there isn't time, right, then we'll end on, why was the equal sign so humble? Why was the equal sign so humble? He wasn't greater or less than anyone else. Okay. I hope you laughed. It's hard to make math jokes. I know they're a little corny, but just work with me. All right. So again, if there's more time, pause the video. If not, pack up. Have a great day. I will try to, again, post videos for the rest of the week, provided I'm up to it. Not feeling all that great, but I was good enough that I can make this video, and I hope it's helpful. Remember to practice for your quiz. Yes, you are getting the quiz next block. and it's on day 1 and day 2. So algebraic equations, how do we clear the fractions, right? Look that over. And your point slope form and slope. All right, day 1, day 2. Study, guys, practice, give this your best shot. Watch the videos. If you haven't watched the videos in the video library on those 2 topics, that might be helpful to help you review for the quiz. All right, this is Action Jackson signing out. Make it a great day.